9.2. Thank you. All ready? Ready? dy dx is actually the rate of change of y with respect to x. Yes? So, what does it mean for dy dx to be positive? It just means that y increases as x increases. That means the gradient is positive. What is then dy dt? If t represents time, then dy dt represents the rate of change of y with respect to time. It simply just means the rate of change of y. Does it make sense? Yes? A lot of physics students here, I'm sure you all can understand. Okay? dy dt just means the rate of change of y. Okay? How fast y is changing. Okay, I don't want to waste too much time. Let's go through these basic results. Can I have attention, please? Look up. Look up. A lot of this formula I write here, okay, just for your quick reference. Okay, a lot of formula will be given in the exam. Okay, so don't worry too much about it. Okay, like all these volume, surface area, etc. Okay, will be given. Don't worry about it. All right, but this one will not be. This one not given. This one must memorize. This one is O-level stuff. Correct? O-level stuff. Okay. Example 6. Let's take a look quickly at example 6. There's nothing new, okay? This is really just O-level stuff. A metal cube is heated, its shape remains cubical. The length of each edge increase at a constant rate of 0.02. Find the rate of change of the surface area when the edge is 50 cm. Now, problem solving, even though it's printed for you, read this question, you must let x be something. Yes? So, what we do is, okay, x is this. Then you write down what you know. Which is the x dt is 0.02 because x increases as you want to find out at x equals to 50, what is the a dt, which is the increase in surface area. So now we recall chain rule. The a dt is the a dx times dx dt. Yes? So, first thing we need to do then is to what? To find, in order to find the a dx, I need to find an equation linking a and x, which is not difficult in this case, which is really quite easy. Sorry. Which is a equals to x squared. How many x squared? How many sides? 6. 6x squared. Which means the a dx is 12x. Does it make sense? If it's too easy, I'll go faster, alright? So now you want the a dt, alright? You want the a dx times dx dt. Dx dt you already know, 0.02. You got to substitute x equals to 50 inside. Can I have attention, please? I know it's easy, but don't make any mistakes in the exam. You have to differentiate first before substituting x equals to 50. Because if you substitute x equals to 50 here, you got a equals constant, you differentiate, get 0. Doesn't make sense. For what I'm saying, you got to differentiate first, then you substitute at x equals to 50. The a dt must be 12 times 50 times 0.02. Because you are making use of this. Yeah? Take it 12. So the rate of increase is just 12 mm squared per second. Now include your units, 12 mm squared per second. Any questions? All okay? Quite easy, right? Example 7. Air is escaping from a spherical balloon. Now, escape. That means dV dt should be negative, okay? Then air is escaping. That means the volume of air is escaping. So dV dt must be negative. When the radius is 5 cm, air is leaving at the rate of 12 pi cm cubed per second. Calculate the rate at which the radius is decreasing at the instant. So we write down what we know. At r equals to 5, dV dt is negative 12 pi. Negative, because it's escaping. Does it make sense? Now you want to find out what is the rate at which the radius is decreasing. You actually want to find out what is this. Yes? So, I don't know why there's a repeat form. Is it printed for you all? This one, no need. Oh? Right. You have that? Don't have? Oh, okay, then forget it. Forget what I said. So the r dt is actually using chain rule r dv times dv dt. Am I right? Chain rule. Now, how do we find the r dv? That means you need to have an equation linking r and v, which is not difficult because v, which is the volume in the sphere, is 4/3 hierarchy. 4/3 hierarchy. So, go to the next column. So from here, you will write down dv dr. That means you differentiate this with respect to r. Is actually 4 pi r squared. Does it make sense? Okay, therefore, when r equals to 5, what do we do? dr dt equals to what? dr dv is 1 over dv er. So you take the 1 divided by this. Correct? Then I rewrite this first. No need lah. It's actually 1 divided by 4 pi r squared. What is r squared? 5 squared. Times. What is dv dt? Is negative 12 pi. You cancel. In the end, you get a negative 3 over 25. So what we are trying to say is that when r is 5, the rate of change of r is negative 3 over 25, which means the radius is decreasing at this rate. You don't put double negative, can? You know what I'm saying by double negative, right? Because you found negative, you say it's decreasing, you don't put negative here already. Can? Follow what I'm saying, right? Because you already say it's decreasing. Okay, don't put negative. Follow? Okay, I'm going through a bit fast, but I think it's quite easy. So let's press on. Okay, let's press on. If you are good, I show you video, okay? Example 8. All okay? Can? Why? Still copying? Why copying so? Are you okay or not? Can, right? Give me some indication, eh? Good, very good, thanks. Okay, example 8. Circular cone. Can I have attention, please? Thank you. 45 degree. What is this 45 degree? This is this 45 degree like that. It's turned upside down. A vertex pointing downwards. Water is poured at 2 cm cube per second. You are supposed to find the rate of the depth at which the depth is increasing when it is 4. Wow, so many things to write. Now, I probably should have left this empty, because actually it's the most important part. Can I have attention, please? Look, actually the most important part is to break this problem down and write all this, right? You say that, okay, I know dV dt is 2, you see water is poured in. You actually want to find dH dt equals question mark, and h goes to 4. Okay? Then you write down volume is actually 1/3 pi r squared h. The question here is actually, this is difficult because you got an r squared, you got an h. The tendency is to say, oh, I differentiate. And then I substitute h in here, and I differentiate. The tendency is to do that because I want h equals to 4. Now you must be very clear which is a variable, which is a constant. I repeat one more time. In this equation, you must be very clear which is a variable, which is a constant. You all write down your own notes, okay? I'll go through. Pi. Is pi a constant or a variable? Constant is just a number, nothing to be scared of. Okay? It's just a number, 3.14. R. R. Is it a constant or a variable? You're still talking, ah? Are you discussing R or discussing what? R, is it a constant or a variable? It's a variable because you imagine water like that being filled. As water goes in, the R is this radius changes. As we have more water, this is R, right? Then we have more water, then R also changes. Correct? Yes? This is R. R is that radius. What about H? Is it a constant or a variable? Also a variable. Because as water pours in, H is the height of the water, not height of the cone. Height of the cone is a constant. You follow what I'm saying? Height of the water is a variable. So must be very clear. This is a variable, this is also a variable. You do not know how to differentiate something with 3 variables. Because V is a variable, R is a variable, H is also a variable. Forget it, don't bother. You do not know how to handle. So the objective now is to express V in terms of only one variable. Do you all follow what I'm saying? Follow? Follow, okay. Now, so therefore, let's break the problem down. I actually want to find dH dt. dH dt is dH dV times dV dt. Because I know dV dt. Okay. The problem now is dH dV is not so easy because I know V is this. If I differentiate this like that, simply, I got a big problem. I want to say this, This is wrong, This is wrong, You cannot just differentiate like this and treat as if my H is a constant. You also cannot differentiate this as if you cannot differentiate as if R is a constant, you cannot differentiate as if H is a constant. You follow what I'm saying? So what do we need to do? We need to do this. No matter how, that is the reason why 45 degrees is given. No matter at which level the water is, if this is 45 degrees, this is R, this is H, these two must always satisfy this idea, tangent 45 degrees must be opposite over adjacent, which is R over H. Does it make sense? No matter where is the water level. Does it make sense? So what is tangent 45? Quickly, don't need to use calculator. 1, very good. So therefore, at any point, no matter where is the water level, the radius and the height must be the same. Does it make sense? Therefore, if I substitute R equals to H into this, I get this. Now, I want to stress this. We are happy because V is expressed in terms of one variable only. We are happy because V is expressed in terms of one variable. Then we can differentiate. Because earlier this expression has two variables, R and H. When you do a tutorial, please make sure that you do that. Must be careful. The moment your expression has two variables, you must be very careful, don't differentiate. For what I'm saying. Okay? So if you do that, then it's easy. We can differentiate with respect to H. Then you actually get the pi H squared. Correct? Now, let's go across to this side here. So now you want to know what is the rate at which you want to find the dH dt. So then you can substitute dH dt is this, make use of this one. dH dV is actually 1 over this. 1 over this is actually 1 divided by this. 1 over pi 4 square times 2. 2 is actually your dV dt. Then you get 1 over 8 pi. Follow? Okay? There you go, answer. They're a bit dry, but we will finish soon. Okay? Okay? Now the next part of the question. Find also the rate at which the area of the horizontal water surface is increasing at the same instant. Let's look at this. The area of the water surface is actually area of a circle. At the top of the cone is a circle, which is pi r squared, which is also pi h squared because r is h. So we use chain rule, we get this. dA dt, which is what you want, equals to dA dh times dH dt. Do you know dH dt? Yes, dH dt is this. So therefore, the only unknown, you don't know this, you know this, you know this. How do we know this? From here. dA dH is actually 2 pi h. Does it make sense? You differentiate once. Therefore, dA dt is dA dH times dh dt, which is 2 pi, h is 4, times 1 over a pi. Correct? Which is actually 1. So final statement, the area of the horizontal surface is increasing at the rate of 1 cm squared per second. So boring. Yeah, watch a video. Really very, very boring.